Hey everyone, thanks again for joining us on the session today and for standing by for a minute while we get a few more people getting access to the session. Can I just get a quick show of hands from attendees that they can all hear me okay? I believe there's a raise hand button yeah, beautiful. Thank you everyone. Love your work. Yeah, obviously we're doing a Sphere Drones webinar series over the next 12 months where we'll try and do a session every month to talk about some of the key things in industry to help kind of raise awareness, I suppose, of the different considerations for drone operators and how drones can be used in industry. So thanks again for tuning in today. The webinar will be recorded today, so if you aren't able to make it and you want to have another look, or some of your colleagues want to have a look, the link will be available after the fact. Some housekeeping things for today. If you have any questions during the session, please feel free to use that question box up the top there. We'll have a question and answer session at the end, and we'll go through all of those questions, and anything we don't have time to get to, we will circle back to off the back of the webinar. So without further ado, a quick introduction for myself. So I'm the Chief Remote Pilot here at Sphere. I started here 8 years ago, came in to get a drone and walked out with a drone and a job, and yeah, obviously been here on an interesting ride ever since. So for those of you who aren't familiar with the Chief Remote Pilot role, I guess that role is to provide support for the team and ensure that everything that you're doing is safe and compliant, legal, etc. But then obviously as part of my role here at Sphere, I've obviously provided that kind of technical support to the team, and then obviously hands on the sticks as well. So lots of demonstrations, proof of concepts, etc. So yeah, it's been an exciting time here at Sphere. So on the back end, I've got a couple of my colleagues as well who are helping support the webinar today. So thanks again to them for helping get this one all together. In terms of the quick overview of the agenda for today, we'll have a quick chat about the regulations, an overview of technology, what the different drone applications in business operations are. Obviously, there's a big chunk in that, but we'll try and get through a couple of them today. Key benefits of using drones, selecting the right hardware and software, and then a couple of case studies, and then some Q&A. Yeah, thanks again to the people who are joining us today. I can see there's a few familiar names on my attendees list, so nice to see you all, gang. In terms of the regulatory environment, so of course, before we get stuck into the nitty-gritties of the technical, hardware, software, and considerations for an actual operator, it is important to be aware of the fact that there are regulations that govern the aviation environment in Australia and in other countries around the world as well, of course. So the Australian environment is governed by the Australian Civil Aviation Safety Authority. So they obviously regulate airspace as well as drones and crewed aviation, so among other things. So it is important that you are aware of those regulations. It is something that people have been getting better at realizing, but often people do grab a drone and think, oh, cool, a new piece of kit, I'm just going to go and fly it, and don't necessarily think that you are going to be sharing airspace with piloted aviation operators. So there are two ways to fly commercially. Of course, you can fly under the excluded category, or you can fly under a remote pilot license with under an operating certificate. Of course, you can fly recreationally, which is a different consideration, which we won't be going into today. But yeah, the two key things for commercial operations is excluded category or under a remote pilot license and an operating certificate. If you do get a remote pilot license, that does, of course, give you the ability to operate as a commercial notification, but to really execute the privileges of that remote pilot license, then you will need to go and get an operating certificate or operate under an operating certificate. So as a very quick overview for you, if you're not familiar with the remote pilot license concept, basically if you want to fly outside the standard operating conditions, so things like you want to fly above 400 feet above the ground, you want to fly at night, you want to fly a heavier aircraft than 2 kilos, etc. There's a few other different considerations, of course. If anything that you want to get permissions for, you'll need to have a remote pilot license and operate under the REOC. If you can fly within the standard operating conditions, some of which I mentioned before, then that's where you can operate under the excluded category, and that's where it might simplify your operations a little bit. So, yeah. So in terms of an overview of drone technology, so some of the people who are on the call, I can of course see acutely aware of the drone technology concept, but for those who aren't, basically a drone is often known as a UAV or an RPA. remotely piloted aircraft or an unmanned aerial vehicle, uncrewed aerial vehicle. They're generally used to capture data, but they of course have a wide array of applications. So it's just almost just limited by your imagination and the regulation, I suppose. But so of course some of the components that make up a drone are, the actual airframe itself, a propulsion and power system, a flight controller to actually, provide the drone with ability to maintain its position and, complete the tasks that's required. Communication link, most of the time, if not all of the time, you'll have a communication link with the remote control with the pilot, and then of course a power supply. And often they'll use a GPS unit. It's not exclusively the case, but often they will use GPS, of course. And then of course there is the GNSS denied environment, which will be we'll have a session later on in the year where we'll talk about the underground environment and GNSS denied environment with the likes of the Helios. So stay tuned for that one. As I said, generally a drone will be a carrier for a payload, and while sometimes from a recreational standpoint, of course, that's part of the allure of having that change in perspective. But often in the commercial space, the drone itself will be there as a platform to carry a payload or a sensor to gather data, and that's basically what it's all about. So those payload sensors can be anything from a standard red, green, blue RGB camera right the way through to a LiDAR sensor or a spraying system for agricultural use. So there's a huge swath of applications available there and payloads available. And as I said, effectively an RPA is a data collection tool for the most part. So in terms of the types of drones, there are of course a few different varieties, and the most common these days is the multi-rotor aircraft. So you can see we've got the Matrice 350 pictured here. But there are other systems that are able to take off and land vertically and transition into a fixed wing style of flight. So that kind of gives you some of the benefits of the multi-rotor operation style while giving you a few advantages of the fixed wing style of operation. And then of course there's hybrid drones as well, which is technically maybe not necessarily a different type, but just another consideration. Hybrid RPA using liquid fuel, they have really long endurance, so you can kind of have the best of both worlds in some I suppose a combination of the multi-rotor and the endurance that you get from a fixed wing. So in terms of the payloads, like I mentioned, there's a variety of payloads available. Red, green, blue cameras, LiDAR, thermal, multispectral, hyperspectral, spraying and spreading payloads, package delivery. But there's a whole other list of payloads available. So if you have a use case in mind, let us know, and we'll see if there's anything for it. So, oops, sorry, don't mind me. So in terms of the different drone applications, so of course, surveying is a very popular one for the use of drones in commercial industry. So using them for things like stockpile volume calculations, mining development and exploration, civil construction, you name it. Inspection and monitoring, so infrastructure inspections on a mine site, perimeter monitoring, security, etc. Spraying and dispensing is another one, of course. So things like pest prevention and fertilizer spraying. But yeah, depends on the kind of utility there for the agricultural environment. Dropping and delivery. So of course you've got things like being able to send a drone. I know that they've been used quite extensively in Australia here by some food delivery and other product delivery services. So it's amazing to see that sort of technology coming through into Australia, which is great. And media, of course. So being able to have eyes in the sky from a still photography or video perspective is amazing. And seeing the advent of drone light shows has been pretty exciting over the last years. So as another option, an alternative or to complement fireworks is pretty exciting. And then water sampling is a big one that's close to our heart. We've done a lot of water sampling over the years. We've developed a water sampling payload, and that's been used quite extensively here in Sydney to do water quality monitoring, which is pretty cool. But yeah, that can be used in a variety of different locations. Being able to get a drone into a place where it might otherwise be unsafe, which we'll kind of get back to. So in terms of the key benefits of using a drone, so of course having improved efficiency, so being able to collect the data more quickly, having autonomous or semi-autonomous workflows there, so you can get data more quickly, you can have a process and turn around more quickly, and being able to get it on demand. One of the things that historically was a problem was being able to get the data and get it turned around quickly enough. If you are using an external party, you have to manage their availability, etc. So sometimes that's easily managed, but other times it's good to have a little bit more autonomy oneself. And one of the big things there, of course, as well, is that we're seeing and the introduction of things like drone-in-a-box technology, which does allow you to have that kind of more 24/7 access to data, whether it's a thermal camera at night to do survey or perimeter inspections, or if you just want to be able to get surveying as soon as the sun comes up, sort of thing. Accuracy, so being able to get higher quality data than historically available as well. So if you previously were relying on external parties who maybe came by once a month or once a quarter to do a survey of an area, it might be something where they do that in a fixed wing aircraft, for example, or if you're using satellite data, being able to use a drone to get much more localized, high resolution, high fidelity data is a pretty amazing capability that's come with the advent of drones as well. And then cost savings and safety, of course. So, being able to operate these drones means that you can potentially do it in a more cost-effective way. You can potentially remove people from a dangerous environment. You don't have to physically go down and inspect something, or set up scaffolding or ropes, etc. And you potentially don't need to shut down an asset to make it safe to go and conduct those operations. So, and then on the right-hand side here, of course, we've got some statistics for the P1. Of course, in Australia, not operating above 120 metres unless you've got the approvals, etc. But those are some examples of the sorts of area that you can cover in one flight with some parameters there. So, of course, one of the big parts of this equation is ensuring that you're choosing the right hardware. So you need to have a bit of an understanding. There's a bit of a chicken and egg situation to some extent, but effectively you need to be able to understand, your surveying and inspection needs. So understanding your accuracy requirements, and that kind of will dictate, how much, and the size of the asset that you need to inspect, and the environmental constraints will dictate, what sort of flight time you require, or what type of aircraft you need, or what type of payload you need, etc. So things like accuracy, data requirements, flight time. If you need to cover a really large area, for example, it might be something where that changes the type of aircraft that you use, because you don't want to be changing batteries every few minutes, well, not a few minutes, but operating location, temperatures, wind, etc. So of course, if you're operating by the sea or in a somewhere where you've got high winds or high temperatures, then you'll need to choose your aircraft more carefully. Things like choosing the right type of drone. So in terms of those equations feeding into this choice, there might be scenarios where a multi-rotor is the perfect tool for you. If it's something where you're covering really large areas, it might be something where you do benefit more from having a fixed wing or a VTOL solution. While the fixed wing solutions were fantastic early on in the game, it is something where the requirement to have a relatively large launch and landing location and being a little bit more impacted by the orientation of the drone due to wind has really kind of provided an advantage for VTOL solutions. So being able to cover those larger areas with a VTOL solution while it takes off and lands in a similar sort of space to that of a multi-rotor drone really makes a big difference. And then if it is something where you need to carry a larger payload and/or you need to fly for longer periods of time or capture more data, then that might be something where you need to look at a hybrid solution there as well. In terms of the payload, of course, the payload is part of a big part of the equation. So making sure that you're choosing the right sensor for the job. There are pros and cons to each of the different payloads available to be used on drones. Some of them are fit for purpose. Others might be able to do the job, but whether it's the right tool for the job is a different question. You can whack in a nail with a screwdriver, but whether it's the right tool for the job is a different question. So depending on the data output that you require, LiDAR, RGB, traditional photography or photogrammetry, thermal, multispectral data, etc. And then the quality as well. So similar to the fact that you could use a mobile phone camera to take a photo of things, if you needed a higher resolution, high accuracy product, you might need to use a larger sensor camera. But there is a place for the various different solutions. The best camera is the best the best camera is the one that you have with you. And so, if it's a matter of not being able to take the drone with you to a specific location, or the camera being, not able to be mounted on the drone, then maybe it's not the right tool for the job. Of course, as part of the equation, capturing the data is one thing. The next part of the puzzle is, management of that data. So you might need to do some post-processing of that data using photogrammetry or mapping. So you might need to use something like DJI Terra or Pix4D. You might be creating 3D models, point clouds, orthomosaics, or digital surface models, or maybe thermal maps. There's a whole swath of different deliverables that come from these sorts of things. And then software integration. So being able to take that data that you've processed and export that to a different location, or effectively and efficiently leverage that data. There's obviously the intention of capturing the data is so that you can make those informed decisions. So there's a whole suite of softwares out there that will be able to help you with that, whether it's cloud viewing or whatever it is. In terms of case studies, so easy example here is, we had a tier 1 mining client who was dealing with safety risks on site, and the traditional methods were a little bit inefficient, so they wanted to try and streamline things on their site. So looking at the Matrice 350 with DJI Zenmuse L2 allowed them to basically go out, capture that data more quickly, more efficiently, and then the data with the L2, one of the benefits of it is that it's very quick to turn around. So being able to utilize that on the site. They obviously had all the imagery for photogrammetry if they needed or wanted it, but the LiDAR data, is often more than enough for what they need. Being able to capture data of their stockpiles, you can use it for a whole range of different applications on site. Of course, being able to keep people out of a pit environment or stop them having to clamber over stockpiles, etc. Makes a big difference to rolled ankles, broken ankles, etc. And then another one here, so survey grade 3D mapping and surveillance. So we had a client in PNG who was looking to implement a drone program to enhance efficiency, improve productivity and safety. And they also had concerns with trespassers who were entering the dangerous location of their mine site overnight. So obviously being able to have eyes in the air and be able to be aware of the fact that there are people, breaching their fences or perimeters, etc., and trespassing on the mine, at risk to themselves and to people on site. They ended up going with a Matrice 350 series there with a P1, so that they could create survey grade point clouds. And then with the H30T, being able to just take that payload off and put that straight onto a Matrice 300 series, 300, 350, just means that they can, have that kind of flexibility and multiple capabilities for the same drone. So as you can see there, the result of them being able to safely and effectively operate drones across their site, completing photogrammetry workflows and producing survey grade point clouds, they've improved their safety and efficiency on site there. So in terms of the different payloads here, we did have some specs on the previous page here. I'll just show you that one there. So that's the L2, the latest LiDAR solution from DJI. Pretty sweet little payload there, very capable. One of the big improvements is it doesn't have that big warm-up time if anyone's used the L1 before. Great solution, the L1, but if you powered off the unit, you have to, and when you power it back on, you have to wait 5 minutes for it to warm up. It can be a bit of a slows things down a little bit. Yeah, I can see love heart there from Danny. You know the pain. With the L2, that obviously is a much more robust product. Really nice to work with. The H30T as well. Really nice upgrade from the predecessors. The predecessors were already really capable cameras, so to upgrade to the H30T is even more impressive. It does have that really big thermal camera sensor there, so that's 1280 by 1024. So previously, for years, the maximum sensor size on a thermal camera was around that kind of 640 by 512 pixels. So to double that is pretty impressive. And then the RGB cameras on the H30, I believe that it was something like 4x the previous H20T payload. So really nice improvement to see there from the H20 to H30. And then, of course, the P1 on the right-hand side here. So I'm a big photographer. I love photography. So seeing a full-frame camera available for the M300, M350 series was really nice when it came out. It's been out for a little while now, but it's still very, very capable, really relevant. Yeah, 45 megapixels on a full frame with interchangeable lenses. It's pretty awesome. One of the big things that I like about the P1 is being able to go and capture oblique imagery. So you can go into a large area and it'll automatically go and take photos in each direction so that you get a really good quality model, and you don't have to do the old double grid pattern if you don't need to. For anyone who's done any photogrammetry work before, they'll kind of know the pain of having to sit there and watch it do double grids. There's still a place for that, of course, but yeah, this just is a pretty nice capability. So that's pretty much it for the quick little introduction to drones. So I'm just going to have a quick look here at some of the questions that we've had come through. So in terms of the questions here, we've got one from Robert Matheson. Hi, Robert, how are you? So as a sole operator, I encounter 3 issues: the cost of RPAS and payloads, second, gaining licenses and approvals. Can anything speed up the process and reduce the overall costs involved? So in terms of the actual question there from you, Robert, it sounds like you're asking about speeding up the process and reducing the overall cost involved. So that's, I guess, in terms of the drone solutions themselves, are you referring to are you referring to speeding up the process and reducing the cost of the operation in the field, or are you referring to the speeding up the process and reducing costs on the licenses and approvals? Where are we, Robert? I'm just having a quick look for your question there, Robert. While we wait for both. Okay, cool. So sorry about that, gang. So in terms of efficiency on site, I suppose one of the big advantages of some of the newer systems is that you are able to improve your accuracy and efficiency on site. I guess there's probably a whole nother webinar to be covering when it comes to improving efficiency and improving efficiency on site. One of the considerations I'd be keeping in mind is that the advent of PPK and RTK technology does improve the ability to maybe reduce the overlaps and things on site, which, obviously I think it's something like for every 10% reduction in overlap, you do reduce your flight times substantially. So being able to be a little bit more aggressive with those sorts of things, will obviously help reduce your time on site and reduce the amount of images that you capture, and therefore reduce your processing time and turnaround, etc. So yeah, that's one thing that you could do, but I think maybe there's a bit more of a conversation there in that one. So we might get back to you off the back of the webinar with that one. I've got another question here from Greg. Have you used a drone to do a bathymetric survey? So we actually have got a bathymetric solution that we're showcasing in October. So the Yellowscan Navigator is actually going to be in the country. Well, it's in the country. And that's going to be utilized for our Yellowscan demonstration tour. So that's a LiDAR-based bathymetric solution. It is something where it's slightly restricted by the turbidity of the water, but there are other solutions for that. So if it is something where you wanted to have a conversation with the team off the back of the webinar, please feel free to shoot us through a message, or I'll get the team to make a note there. And Robert, I just noticed your second part there, so I will get back to you off the back of the webinar if that's okay. The question there from Danny. Hey, Danny. So Danny's asked any question, if I have any thoughts on when the P2 will be released and any features that we're hoping it will have. Look, from my side, I haven't heard anything yet about a P2. In terms of a next step, it's obviously a bit of a balancing act between, having a high megapixel count or, a larger sensor size, if it then, means that you end up capturing a whole bunch of extra data. So I think I think the P1's pretty solid as it is, but I guess the logical thing would be, there's always room for improvements in terms of lens technology, weight saving, sensor size. Obviously a full frame is amazing, but it'd be awesome if DJI released a medium format camera. So, but yeah, it's all a bit speculative at this point. But yeah, anything else that I think of, I'll certainly get back to you. Someone's asked about the M30T. So the Matrice 30T is an awesome unit. It's fantastic for the search and rescue applications, inspection. Obviously, one of the big benefits is that you are able to have a turnkey solution that you can just kind of get out of the box and go. Really quick to deploy. Really nice high zoom camera, good megapixel count, etc. Obviously, it is over that 2 kilo mark, so something to keep in mind there. But yeah, really. Awesome kind of I suppose in between solution between the Matrice 3T and the Mavic 3T and the Matrice 350 with the H30 series. M30 is that really good kind of middle ground. In terms of the open source software for post-processing LiDAR data. So that's a good question, Greg. I believe that we might have another session later on in the year around LiDAR data, but typically with LiDAR processing, they usually have proprietary post-processing software that will be used to post-process the data for that particular sensor. Once you step out of that ecosystem, there is a whole bunch of different third-party softwares available. TerraSolid is one that comes to mind. If you do want to have a look at that, but I don't believe that's a free software. But QGIS is quite good. I'd have to double check whether they have a LiDAR module. And the other one that comes to mind is Global Mapper. Global Mapper is a really good solution. So if you're interested in that, let us know. We can have a conversation around that. And then Shane, just circling back briefly to your M30 question. So the long answer to your question is that it really does depend on exactly what you're looking to do with the solution. Like I said before, you can use a screwdriver to hammer in a nail, but whether it's the right solution is a different question. So you may be able to do the job. There may be some improvements that you can get from using a different system, but it may be that it's just quick and easy and at that kind of sweet spot in terms of price and capability and ease of deployment and things. So yeah, if you want to give us a bit more information about what you're looking to do, we're happy to have a conversation there. Phase 1 setup. So in terms of a phase 1 setup, if it is something that you're interested in a phase 1, I'll have a chat with the team and we can reach out to you and see what you're looking at there. But there are a few different options available, of course, to allow you to put a medium format camera underneath the Matrice 300 series or other platform. So yeah, let us know if there's anything you need there. But being mindful of time, everyone, I think that I actually I've got an operation. I've got to jump into the remote operations center shortly. But really appreciate you all taking the time out of your day to join us. Sorry that this was a bit short and sharp, but it's good to I think to have a bit of a short session, and then we can kind of follow up off the back. So I think yeah, if there's anything else anyone needs, please don't be a stranger. Otherwise, we'll see you next time. Thanks again, everyone.